3I Atlas has slipped away. After a whirlwind passage through the inner system, our newest interstellar wanderer is heading back into the dark it came from. Luckily, our largest observatories and sensor arrays caught a final clean look as it departed. As a result, we now hold more data on 3I Atlas than on any interstellar object to date. That gives us the first real chance to separate speculation from evidence and to say what this thing likely is and what it almost certainly isn't.
By December 2025, Earth swung into its tightest approach with 3I Atlas, ending months of solar glare that hit it through October and November. In that time near the Sun, heat and radiation profoundly altered the visitor, so a different face was expected, and that's exactly what Hubble recorded: a pinpoint nucleus wrapped in a thick, luminous coma of dust and gas. Standard comet behavior would show a long, trailing tail, but 3I Atlas refuses to be standard. Process the same frame with a rotational gradient filter, which suppresses circularly symmetric glow and isolates linear features, and the jets pop out. Here's the odd part. The prominent tail on the left points towards the Sun. For nearly the entire observing arc, 3I Atlas has displayed a Sun-facing anti-tail, the inverse of normal comets whose tails are blown anti-solar by the solar wind, a continuous flux of charged particles and photons from the Sun that acts like wind on unbound material. Closer to the Sun, the anti-tail should shrink under stronger pressure. Instead, the sunward jet is larger and brighter, implying substantial internal energy is driving material outmuscling the solar push. On the opposite side, a trio of narrow plumes forms a near-perfect triangular pattern, one where a common tail should be, flanked by two sibling jets. Patterns like this can look unnervingly engineered, but a single snapshot isn't a verdict. Still, these powerful outflows offer a window into the interior, and that's where clues stack up.
Those jets sample the subsurface. Back in mid-2025, spectra showed a coma dominated by carbon dioxide, highly atypical for comets native to our system, which are overwhelmingly water ice with only trace CO2. 3I Atlas inverted that ratio until sunlight rewrote the script. Using radio facilities like South Africa's Meerkat, astronomers peered through the murk and found copious water in the outflow once heating ramped up. Beneath the skin, 3I Atlas is water-rich. When warmed enough, that reservoir vents furiously. That pivot hints at how the object formed and why it behaves so strangely. Brief aside on how this show comes together: research, scripting, iterative edits, motion graphics, 3D, animation, asset wrangling, timelines, all moving in sync. We use tools like crad.ai to assign specialized helpers for different stages, keeping projects structured, handoff smooth, and logistics out of the creative lane. It doesn't replace editors or animators. It removes friction so the team can focus on craft. If you're curious, visit crad.ai/space and use code SPACE for a discount and a 14-day money-back guarantee. Thanks to crad.ai for helping keep the space race running.
Part 4. An ancient core with a cosmic ray's skin. Here's a leading scenario. 3I Atlas is primeval, older than Earth and our Sun, born far from here. It likely spent eons in deep interstellar cold, seldom coming near any star. We can't backtrace to its birth system. We only know it approached from the galactic center direction and hasn't passed within a light year of a star for at least 10 million years. But space isn't empty. It's steeped in galactic cosmic rays, high-energy radiation from supernovae and other violent events. Over billions of years, those rays can alter exposed surfaces, breaking bonds, rearranging chemistry, transforming water and carbon into CO2, and building in a radiation mantle, a toughened crust that hides a more normal interior. In this view, 3I Atlas began as a typical water-ice comet in a system like ours, was flung out by a gas giant's gravity, then slowly acquired a chemically modified shell in the interstellar night. Near our Sun, heating fractured that shell. Patches cracked open, liberating exotic, crust-borne volatiles at first, the CO2 phase, then, as the skin failed more broadly, unleashing water-driven jets bursting through vents and fissures, spraying in odd directions, and producing the anti-tail. In simple terms, the comet isn't weird, its long-baked armor is, and that shell fooled us.
If you're still on the fence about alien craft, here's what the professional alien hunters report. The SETI Institute, founded in 1984 to study life's origins and search for intelligence, threw a suite of instruments at 3I Atlas over the past month: IR, UV, radio, microwaves, combing for technosignatures. They report nothing. No transmitters, no comms, down to thresholds roughly 10 times weaker than a cell phone. If it had been phoning home, they say we'd have heard it. Meanwhile, the Black Vault filed a FOIA with the CIA for communications related to 3I Atlas and got a classic Glomar reply. We can neither confirm nor deny the existence of such records, adding that even acknowledging records' existence is classified. That invites questions. Why classify anything about a snowball? But likely we'll never see those files. What we will see is more visitors. With the Vera Rubin Observatory coming online, capturing wide, high-resolution sweeps of the sky every few nights, we're about to enter a census era. We've spotted 3 interstellar passers in a decade, implying they're common and we've simply been blind. The payoff is huge. With larger samples, we'll sort typical from truly odd, because the truly odd is out there, waiting to be seen.